Algebra 1, let's start working through lesson 3. Estimating centers. Sorry about that. Estimating centers and determining the mean as a balance point. And let's jump right in. Your previous work in mathematics involved estimating a balance point on data distribution. Same thing as I said the last 2 lessons. If you don't have this previous work in mathematics, it's okay. We'll learn it together now. If you have any questions or don't understand, you just need to ask. Okay? So let's review what we've learned about a balance point of a distribution. If we pretend I have a 12-inch ruler with several quarters taped to along the ruler. The broad side of a pencil is placed underneath the ruler to determine here's my pencil to determine the approximate balance point of the ruler with the quarters. So if you pretend, hold on a second. I've got some quarters here. If I drew the quarters there and assumed that was right in the middle, the ruler should stay balanced. If I take one of these quarters off and I move it in, the ruler is going to flip down on that side, right? If I take this one off and move this one in equally, it'll stay balanced again. I mean, I could do lots of things. I could put 2 quarters on this side, 1 quarter on that side. I could find the middle, the balance point, with 2 quarters down here and only 1 right there, because this is going to be, it's closer to center, it's going to flip down, but this is going to keep it balanced to keep it upright. We could keep playing. If we were in class today, I'd have some rulers and we would try to find the balance point. 3 quarters here. Where would this quarter have to be to balance it? Maybe there, maybe in a little bit further. I put another quarter, 5 quarters here. Can I even balance it with 5 quarters? I don't know. So let's look at this. Consider the following example of quarters taped to a lightweight ruler. Sam taped 3 quarters to his ruler. The quarters were taped to the positions 1 inch, 9 inches, and 11 inches. If the pencil was placed under position 5, do you think the ruler would balance? Why or why not? 5 being right there. I don't think so. 5 wouldn't work. Okay, the quarters at 9 and 11 pull the balance off. Pull the balance towards that side. So these 2 quarters pull the balance more to that side, right? If the ruler did not balance, would you move the pencil to the left or the right of the 5 inches to balance this ruler? What do you think? Well, this is a bit heavier over here. So to balance it, what would I do? You could actually move the pencil to the right because the quarters at 9 and 11 pull the balance to the right. All right, let's work on estimating a balance point for the ruler. Complete the following based on the position that you may or may not selected. So let's estimate a balance point. I've got that ruler. I've got a quarter on, let me go back and look at it. A quarter on 1, and a quarter on 9 and 11. 9, 10, 11, 12. 12 should be at the end, though. 12. Oh, this is terrible. I have a ruler. 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. I have a quarter on 1 and a quarter on 9 and 11. estimate my balance point. So, I don't know. What'd you guys pick? Let's pick 6. 1, 2, 3, 4, 5, 6. Notice I'm just putting an X there. So let's do distance from the quarter to your estimated balance point. From 1 to 6 is 5, from 9 to 6 is 3, and from 11 to 6 is 5. What is the sum of the distances to the right of your estimate of the balance point? Okay, so on the right side, the sum of my distances is just plain old 5. That was the left side. On the right side, which is what it's asking, it was 5 plus 3. So to the right side of your estimate, which is my X, it's 5 plus 3, which is 8, right? Okay, the next page on my slide is going to ask what is the sum of the distances. Did I say differences earlier? I hope not. What is the sum of the distances to the left of your estimate of the balance point? So the left side was just plain old 5. Do you need to adjust the position of your balance point? That's number 6. Do you need to adjust the position of your balance point? If I've got a ruler balanced at 6, and my distance on one side from the values is 5, and my distance on the other side, the sum of my distances is 8, I think I need to move my balance point, right? Because I want these two values to be equal. Sorry, here was 5, and this one was 6. Yes, an adjustment is needed. The real balance point is found by increasing the distances to the left. So this is my balance point. This was 5, and this was 8. To make these even, I need to increase the distances to the left, so make this number larger, and decrease these distances, make these smaller so that they're equal. Okay, these two numbers need to be equal, or as close to equal as possible, right? All right, let's calculate the mean and the median of the position of the quarters. Just a second. The mean is the average. I'm going to do 1 plus 9 plus 11 over 3, which is just plain old 7. And the median is the middle number, that is 9. So does the mean or the median of the positions provide a better estimate of the balance point for the position of the 3/4 taped to the ruler? Explain why I made this decision. Well, which one is it? Is it the mean or the median? Well, actually, it is the mean. Provides a better estimate of the balance point. Why, do you ask? Well, if I selected the mean position of 7 as the balance point, this is at 1 down here, and this is at 11 and 9, with my balance point of 7, that means the distance here is 6. The sum of the distances here is 2 plus 7, 8, 9, 10, 11. My distance from the balance point has evened out. Okay, the balance point is the position in which the sum of the distances to the left and to the right are equal. Okay, if we use the median of 9, my left would be 8, and my right would be 2. Way off. Okay, that would not balance those 3/4 on the ruler. All right, let's try something else. 22 students from the junior class and 26 students from the senior class at River City High School participated in a walkathon to raise money for the school's band. Dot plots indicating the distances in miles students from each class walked are as follows. Estimate the mean number of miles walked by a junior and mark it with an X on the junior class plot. How did you estimate the position? I don't know. I guesstimated. We're going to go with right there. See what happens. Okay. I guessed 7 because it looked balanced. It made sense to me, right? Yeah, it could be anywhere. You just have to pick something and tell me why. What is the median of the junior data distribution? I'm going to use my calculator and put everything in a list and come up with my median. Hold on a second. All right, the median, which is the middle number, is 8.5. It's halfway between the 11th and 12th person. So 11th and 12th people are right there. Okay, is the mean number of miles walked by a junior less than, approximately equal to, or greater than the median number of miles? If they are different, explain why. If they're approximately the same, explain why. So I went ahead and did my one variable stats in my calculator, and I got a mean of 7.04 to be exact. We're going to just say 7 though. So the mean is less than the median, which is important. Oops, median. So the small cluster of data values to the left, you've got a mound here and this pulls it that way. This is my tail. The small cluster of data values to the left pulls the mean to the left. The median's not affected by the cluster to the left. We have a median of 8.5. Let's see, I can do this in blue. A mean of 7. This tail pulls my median to the left, right? How would you describe a typical number of miles walked by a junior in this walkathon? Here we've actually calculated things so you can answer it a lot better. And it appears that the mean underestimates. It's not the best value, right? So it underestimates. Only 8 students walked, less than the mean. So 8 students were less than 7. And let's see, how many does that leave? 14 students walked more. Okay, that's a lot. So I would say that the median, and you should say that the median is a better description. All right, the distance walked in miles by seniors. Estimate the mean number of miles walked by a senior. Mark it with an X on the senior dot plot. How did you estimate this position? I'm going to say it's about right at 6, give or take. Right? We've got very symmetrical. So I'm going to say right around 6, maybe around 7, maybe somewhere in between. But this is a very symmetrical dot plot. It's really nice. So because it seems symmetric, I would say about 6 to 7. Any answer around in there would make sense. The balance point, oops. Is probably right in the middle. Can't spell. Cool. What is the median of the senior class distribution? So if you count off each one, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yep, 7. The median is 7. Cool? Let's see what the next question says. Estimate the mean and the median of the miles walked by seniors. Since the distribution is symmetric, the mean and the median should be symmetric. The mean should equal the median. That's what I meant to say. We already saw that the median was 7, so the mean should be about 7 because it's symmetrical. How would you describe a typical number of miles walked by seniors? Since those are equal, you can pick them. It is 7, right? When your mean and your median are equal, that means your data is very symmetrical, and your typical number should be the mean or the median. All right, a junior from River City High School indicated that the number of miles walked by a typical junior was better than the number of miles walked by a typical senior. Do you agree? We said that the typical miles walked for a junior. Let me go back and look. So I'm going back. Number 11. The mean was an underestimate, so we were going to go with the median. And the median was 8.5. So for the junior class, the median was better, and it was about 8.5 miles. And then the senior class, you could use the mean or the median, and that was about 7. So going back to question 16, the median's a better indicator of the junior class. The median was more than the median of the senior class. So we definitely have more for the juniors. Finally, the 25 sophomores who participated in the walkathon reported their results. A dot plot is shown below. That's hilarious. People either tried or they didn't. It's a U-shaped distribution. We haven't seen one of those yet. Half the sophomores walked on the low end and half on the high end. Let's see. That's for the sophomores. The juniors was skewed. And the seniors was very symmetrical. Estimate the balance point of the sophomore data distribution. Well, if you count all of these dots, half of them are on the left and half of them are on the right. So an estimate would be about 5, since we have half on the left and half on the right. What is the median number of miles walked by a sophomore? Let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's awful. I don't know why that's so big. There we go. So that would be, here we are, 8, and then 1, 2, 3, 4. 1, 2, 3, 4. That one right there is my middle point. So the median, the median is 2. How would you describe the sophomore data distribution? Pretty stinky. Like we said, it's U-shaped. The values are either small or large. Nothing in between. The mean and the median are not good indicators. Mean and median are not good indicators. For the typical distance. They're both stinky. All right, that's all I have for today. Good job.